Alright, now we are going to find out how do we form the formula for a Young double slit interference experiment. Okay, how do we form the formula? Before we can find how to form the formula for Young double slits, there are a few terms that we need to identify first. Okay, first of all, okay, let's check the this setup for Young double slit. We have two slits, S1 and S2. We call it double slits. So the distance between these two slits is we use a symbol D. Okay, this D is called separation between the two slits. Small d is a separation between the two slits. And then here you can see there's a screen here that display the interference pattern of the double slit. Okay, so this is the screen. Okay, I should just write down. Okay, this is the double slits. This here you have two double slits, and this is the screen. Okay, the screen, and this is the interference pattern. Okay, this is the interference pattern. This is the interference pattern that you get on the screen, right? Okay, so D is the separation between the two slits, and big D, small d is the separation between the two slits. Big D is the distance of the screen from the double slits, from the source. Okay, distance of the screen from the source, and then here you can see, okay, from here, this one, okay, here you can see a central bright fringe because it's just right at the center between the two slits. Okay, so this is the central bright fringe. All right, central bright fringe. And then we have YM. What is YM? YM is actually position of a certain fringe, no matter it's dark fringe or bright fringe, from the central bright fringe. So YM is the position of fringes measured from the central bright fringe. We always measure from the central bright fringe. So YM is measured from the central bright fringe. Yeah, the position of bright fringe or dark fringe from the central bright fringe. Okay, and then here delta Y. Delta Y is the separation between two consecutive bright fringe, or separation between the two consecutive dark fringe. You can see delta Y for between the bright fringe and the dark fringe, they are equal. What I can say is, like you see here, this is the delta Y between the two bright fringe. Actually, the delta Y between the two dark fringe is also equal, because you can see this, the distance between the two bright fringe and the distance between the two dark fringe is equal. Yeah, this is a regular interference pattern. Okay, like a zebra line. Okay, so the delta Y, I can say is delta Y between the two bright fringe. Between the two bright fringe is equal to delta Y between the two dark fringe. So, and then what's the formula for delta Y? We will discover later. Yeah. Okay. So, okay, you have now you have identified all the terms. Okay, the small d, separation between the two slits. Big D is the distance of the screen from the double slits, and YM is the position of fringes from the central bright fringe. Okay, and delta Y is a separation between the two fringes. So you're okay already know all the terms. Now let's find out how to derive the formula for double slits. Okay, so to derive, we need to discover two triangles. I start off with the big triangle. Okay, big triangle. Okay, big triangle. Which one is the big triangle? This is the big triangle. Maybe let's draw out the big triangle. Okay, the big triangle is this one. Okay, from the center between the two double slits, yeah, from here. So you can see this one. This is the big triangle. Can you see that? Yeah. This is the big triangle. Okay. This is the big triangle. Okay. Let's look at the big triangle. So this big triangle is actually a right angle triangle at over here. Yeah, it right angle at over here. You see, this is the right angle. Okay. Now when we use tangent theta. We use tangent theta because it's a right angle triangle, so we can use tangent theta. Tangent theta is we know that it is opposite. It is opposite over adjacent, isn't it? Tangent theta. Tangent theta is opposite over adjacent. So where is the theta? This is the theta. Okay, this is the theta over here. Okay, this is the tangent, the theta. So tangent theta is opposite over adjacent. So what is the opposite? This is the opposite. Here is the opposite. Okay, opposite over adjacent, and this one is the hypotenuse, isn't it? But tangent theta is opposite over adjacent. Opposite is ym. That means ym. What is ym? It is the position of fringes from the central bright fringe. Okay, ym. So it's ym. Over opposite over adjacent. Adjacent is the distance of the screen from the double slit. Adjacent is the big D. So this is the one, big D. So opposite over adjacent is ym over big D. Yeah. I just write over here. This is the big D. Okay. Ym over big D. So you get this one. Tangent theta is ym over big D. All right. Okay, now we have this formula already, tangent theta equal to ym over d big D. Now, the next triangle is a small triangle, which is this one. Yeah. Now we can write off this one. Okay, write off that one. Now let's look at the next triangle. The next triangle is this one. Okay, look at this. Look at this part. Hold on a second. Yeah. The small triangle is this one. Okay, I want you to look at this triangle. Yeah, this is the triangle, small triangle. Okay, do you see that? And this triangle also right angle triangle at over here. Over here. Okay, over here. Right. Now, for this small triangle, we use sine theta. Which theta we refer to? Yeah, this one. This is the theta here, over here. This is the theta. Okay? So this right angle triangle. So which one is the hypotenuse for this one? Okay, hypotenuse is this is the hypotenuse. Okay, this is the longest one. This is actually the hypotenuse. And what is the opposite? Opposite to this angle, the delta L over here. This is the opposite. And what is the adjacent? Adjacent to this theta over here. This is the adjacent. Okay. So now we are using sine theta. So sine theta is opposite over. Sine theta is, what is sine theta? Opposite over hypotenuse, isn't it? Sine theta is opposite over hypotenuse. So opposite is delta L. Opposite is delta L over hypotenuse. Hypotenuse is the small d, the separation between the two slits, the small d. This is the one. Okay, so opposite over hypotenuse is delta L over d. Delta L over d. Okay, that's a small triangle. Sine theta is opposite over hypotenuse, which is delta L over D. Delta L over D. Okay, let's look at this delta L. Why do we say this part is the delta L? Is it really delta L? Okay, is it really delta L? Look at here. Which this from S1 to this position. Okay, maybe we can label here. This is the fringe. Okay, F. Okay, this is the fringe. So from S1 to F. Okay, from S1 to F, that is the path for the first wave. And then S2 to F, that's another path for the second wave. So what is the path difference between S1 and S2? Of course, it's this part, this delta L over here, isn't it? This is the delta L. This is the. Still remember how do we find the path difference for the which one already? Yeah, the path difference. See this one? So S1P, S2P. S2 travel a longer distance by this amount. You see that? How do we find the delta L? We draw a a normal line. We draw a normal line downwards. So here you see, you can see here there is a small triangle over here. Do you see here there's a small triangle over here? Which is a right angle triangle. So this part is the delta L, the path difference. So this path difference, this is the delta L. Understand? And we are our theta is over here. This is our theta. Okay, and this is the right angle triangle. So this part is the delta L, the extra distance by the second wave. Okay. So let's look back to my double slit. So this is the delta L, yeah, the extra distance of the second wave, delta L, yeah. So which is the opposite for this small angle triangle theta. Okay. This is the delta, the extra distance of the second wave. So now, if this delta L, if this delta L, we have learned this double slit is a in-phase source. We learned this double slit is an in-phase source. Yeah, two in-phase sources. That means this double slit is a two in-phase sources. If in phase, if delta L is equal to m lambda, multiples of lambda, it will form bright fringe. But if the delta L is equal to m plus half lambda, you will get dark fringe. That means if the, what I can say is if the delta L over here, if the delta L, the extra distance, the path difference between S1 and S2, okay, if the path difference delta L is equal to yeah, if this delta L is equal to m lambda, you will get bright fringe. You will get bright fringe on the screen. Understand? Get bright fringe on the screen. But if this delta L equal to m plus half lambda, then you will get dark fringe. You will get dark fringe. You will get this dark fringe on the screen. Okay. So why will we use delta L m lambda equal to bright fringe and m plus half lambda equal to dark fringe? Because we are using two in-phase sources. Because double slits, we are learning. They are using in-phase sources. Why in-phase? Why it is in phase? You have learned already, right? Why these two sources they are in phase? Because we have learned already earlier. Because the distance of the two slits, is equal from the same light source. Is equal from the same light source. So these two sources they are in phase because they are the same distance from the same one light source, the single slit, yeah, earlier. So because they are same distance, they are these two coherent source, they are same distance away from the one source. That's why they are in phase. So Young double slit is actually two in phase source. Understand? That's why in the end, when delta L equal to m lambda, you get bright fringe. M plus half lambda get dark fringe, which is what I emphasize over here. Okay. If you're using in phase source, then if the path difference is m lambda, multiples of lambda like 0 lambda, 1 lambda, 2 lambda, 3 lambda, you get bright fringe. But if it's m plus half lambda, like half lambda, 1 plus half lambda, 2 plus half lambda, you get dark fringe. That's the formula. Understand? If anti-phase, then it becomes opposite. So that's why it's very important to identify either Young double slit is in phase source or anti-phase source. By now, we already know that Young double slit is categorized as in phase source. Yeah, Young double slits. Okay, Young double slits. This one, say, Young double slits is under in phase source. Okay, in phase source. All right. Okay. Now, let's look back to our formulation for the yeah. Okay. This one. Yeah. Let's look back to how do we form the formula. Okay. So later on you will see the delta M lambda because it's an in phase source. In phase source, that's why delta M lambda is bright fringe, M plus half lambda is dark fringe. You will learn about later on. But before that, before we find the final formula, let's look at this one. Let's look at this one. You see, this theta actually is this. What I can say is the theta over here. You can see this is the small triangle, and this is the big triangle. Over here, you can see this the big triangle. Yeah, you can see the big triangle over here, and this is the theta. This is the theta. Okay. These two angles, these two theta, this theta and this theta, they are same. They are same angle. Yeah. This theta and this theta, same angle, same theta. Yeah, same theta. That means if let's say if this theta is let's say 0.1 radian. So this the angle theta for the big triangle, this theta is 0.1 radian. This theta also 0.1 radian. Also 0.1 radian. They are equal angle. Yeah, equal angle. Now, I just want to remove some information over here. Okay, let us remove. Sorry. Okay. Now. Okay, let us remove some information here. Yeah, I don't want to be so messy here. Okay. Yeah, this one also, and this one. Yeah. Okay, now good. Also, yeah. Okay. Now, you see here, this theta is this angle theta is actually this theta over here. Yeah, is actually a very small angle. Yeah, very small angle. Why is it a very small angle? Because we are comparing between the small d and the big D. Small d, you learned before about interference pattern. In order to have a nice stable interference pattern, the condition is this small d need to be almost equal to the wavelength. This d must be almost equal to the wavelength. That means wavelength. How long is a wavelength? How long is a wavelength? Wavelength is very small. Okay, you learned already about this before, about what is the condition for interference pattern. This one, you see, to have a stable, in the previous video you learned, to have a stable interference pattern, one of the condition is, of course, you must have a coherent sources, same amplitude. Okay, one of the conditions for interference pattern, you must have a very small distance between the two coherent source. The two slits, what I mean is between the between the two slits. Did I draw somewhere? Yeah, between the two slits. Between the two slits. Yeah, the two slits. The two slits. The S1 and S2. They must be very close to each other. The separation between the two slits must be very close to each other. Cannot be very far apart. S1 and S2 cannot be very far apart. It must be very close to each other. How close is it? This D need to be almost equal to the wavelength. In order to have a nice interference pattern, these two slits need to be very close to each other, almost equal to the wavelength. How long is a wavelength? How long is a wavelength? Okay, let's look. How long is a wavelength? Wavelength, let's say the wavelength of red light. Okay, wavelength of red light, if we are using red light, is around 700 nanometer. 700 nanometer. That means 700 nanometer is around how big? Is around 0.7 micrometer. That's small. You know, the D need to be almost equal to this wavelength, which is the D need to be almost equal to micrometer. You know, D is measured in terms of micrometer. So it's very small. Yeah. So we can say D is very small. Can you see that? D is very small. But if you compare with the big D is the distance. Yeah, maybe I just want to remove this first. Okay, remove this. Okay, now compared to big D is very far away. How far is this screen? How far is the screen from the double slit? How far is it? The big D? Big D is actually around a few meter. We can say maybe big D is around 10 meter away. 10 meter. So what I can say is this D is in terms of meter. Okay, in terms of meter, and small d is in terms of micrometer. So is the angle theta big or small? Is the angle theta big or small? Let's take tangent theta. Let's take a tangent theta equal to this one. How to say? The distance between them. Okay, is very small. Okay, what I can say is very small, and this one is very big. So since this is a very big, very long distance away, and the however the separation between the two slits is so small, that's why the angle theta become very small. The angle theta become very small, because this separation is in terms of meter, but the separation between the two slits is in terms of micrometer. So that's why yeah, this theta is actually very small. Yeah, or I can say like this. Yeah, like over here, like these two slits. These two slits is very small. Okay, but this distance is very big. Very far away. So that's why when this is very small, compared to the distance d, yeah, so this is very far away, to form a very small angles over here. Okay, this is the central bright fringe, and this is the first bright fringe. So that's why it turns out the angle to be very small, the theta over here. Understand? Because why? Because the separation between two slits is too small. So this theta is actually very small. To have a very big, the ym is become obvious after only a very small angle. So this theta is actually around maybe 0.1 radian. 0.1 radian. So now I want you to look at this this one. Okay, this theta is actually very small, maybe is around, this theta is around 0.1 radian. Now I want you to use your calculator. To calculate. Okay, calculate the tangent theta, which is tangent 0.1. What do you get? Okay, let's calculate tangent 0.1. Tangent 0.1. Make sure you change your calculator. Into radian. Your theta must be in radian. So let's calculate tangent 0.1. Okay, tangent 0.1. What do you get? You get what I get from here is 0.10033. I got this value. Now let's calculate the sine theta. Sine theta equal to sine 0.1 also. Sine 0.1, what do you get? Sine 0.1. I get around 0.099833. Oh, you see that? Both of these, they are almost equal to 0.1. Theta is 0.1. The tangent theta is also almost 0.1. Okay, almost 0.1. This one, sine theta, also almost 0.1. Do you see that? Also almost 0.1. So that's why when the theta is very small, very small, so you use your calculator to calculate very small in terms of radian, 0.1 radian. That's why I can say tangent theta is almost equal to theta itself. Sine theta also equal to the theta itself, and that's why sine theta is equal to tangent theta. When theta is very small, tangent theta is almost equal to the sine theta, almost equal to the theta itself. Yeah, you use a calculator to prove it. All equal to almost 0.1. All equal to theta itself, 0.1. So when theta is very small, because why I can say why theta is very small, because this d is very far away in terms of meter, but the separation between two slits is very small in terms of micrometer. How big the difference? How big the difference you see between the micrometer and meter? So that's why that's why the interference pattern also form not very far away. If compared to the big separation, big D. That's why the theta become very small. Yeah. So they are almost equal. So tangent theta is almost equal to sine theta. So because they are almost equal, we can equal them. Yeah, we can equal these two. So I just want to write off this one. Okay. Now, because sine theta equal to tangent theta equal to sine theta, so I can say is this one y over d is equal to delta L over d, because is equal because tangent theta equal to sine theta, so ym over big D is equal to delta L over small d, equal. Okay, so if they are equal, so I can cross multiply this one, the big D can cross multiply to the top. Okay, ym, so I cross multiply, so I got this one, ym equal to delta L d over small d. Okay, we almost get the formula for double slit. Now we already learned that the double slits is an in-phase source. Yeah, these two sources, they are in-phase source because they are same distance away from the single source. These two are in-phase source. So if in-phase source, what I can say is if they are both in-phase source, that means to form a bright fringe, to form a bright fringe, the delta L need to be equal to m lambda. To form a dark fringe, the delta L is equal to m plus half lambda, isn't it? So in phase source, so that's why okay, because double slit is an in phase source, the bright fringe, to produce a bright fringe, the delta L must be m lambda. So that's why this delta L over here, can see the delta L over here? Delta L over here. So to form a bright fringe, the delta L substitute with m lambda. For the dark fringe, the delta L substitute with m plus half lambda. That's why we got this formula. This is the formula. Ym equal to m lambda d over d is for bright fringe. Ym equal to m plus half lambda d over d is for dark fringe. So you see this highlighted part, this m lambda is actually delta L. This m plus half lambda is actually the delta L. Okay, m lambda is for bright fringe. Okay, m plus half lambda is for dark fringe. Why like that? Why m lambda for bright fringe? Because once again, I just want to emphasize again, double slits, or sometimes we call it as two slits, is category under in phase source. Category under in phase source. If in phase, what you have learned before that, if in phase source, the delta L bright fringe delta L must be m lambda, dark fringe delta L must be m plus half lambda. Okay, that's for double slits. This one lah. Okay. So conclusion for bright fringe double slits, m lambda d over d. For the to get the bright fringe, the dark fringe is the ym is equal to m plus half lambda d over d, and this m start from 0. Okay, can be 0, 1, 2, 3. Yeah, positive, negative, because got both side. Yeah, got top part and bottom part. Okay, so that's how we get a formula for double slits. Understand? Now, delta L delta Y. Now I want to talk about the delta Y. How to get this delta Y between two consecutive bright fringe or two consecutive dark fringe. So what I can say is over here. Yeah, over here. The separation between two consecutive. Sometimes we say two consecutive, or sometimes we say two successive. Next to each other lah. Two consecutive or two successive bright fringe or dark fringe. This is how we get delta Y equal to it's like we can say maybe we can use, okay, you see like this one. This is the central bright fringe, and which is what I can like this one. The central bright fringe actually is a 0 order bright fringe, and then here we have our first bright fringe. Our first bright fringe is actually the first order bright fringe. Okay, and then we have a second bright fringe. This is the second order bright fringe, and then here we have third order bright fringe, and then here the next one is the fourth order bright fringe. Fourth order bright fringe. So let's take delta Y between fourth order bright fringe and the third order bright fringe. So here that's why we substitute ym plus 1 which is equal to y 4 minus y3. Yeah, the fourth order and the third order. Yeah, what I'm saying. Yeah, the fourth delta Y between the fourth order and the third order. So so we take y4 minus y3, which is we can say is like this one, which is we taking so delta y. What's the formula for this? We are using bright fringe now, yeah, bright fringe formula, yeah, because it's in terms of m lambda, yeah. You can see m lambda is for bright fringe, yeah, m lambda is for bright fringe. So we are taking the fourth order and the third order, so it's like this is m plus 1 means let's say I take m equal to 3, so m plus 1 is equal to 4, so it's equal to what I can is 4 lambda d over d minus the 3 lambda d over d, yeah. So this one just go. We are using bright fringe. So 4 lambda minus 3 lambda. What do we get finally? What do we get finally? We get 4 lambda. 4 lambda minus 3 lambda. Of course, you get lambda. Left with only 1 lambda, isn't it? Left with only 1 lambda. D. This is for bright fringe. This is for bright fringe. Understand? So the separation between the two consecutive, the separation between the this is the fourth order bright fringe, and this is the third order bright fringe. You see, between the fourth order bright fringe, between the two consecutive bright fringe, the fourth order bright fringe and the third order bright fringe, the separation between them is lambda d over d, which is this one. Okay. Actually, I'm taking the, you see, I just want to remove all this, yeah, remove all this, remove all this, yeah, remove all this, yeah. You see that? How to find delta L, delta U, delta Y? The separation between the two fringes is actually we take the long minus the short. You see the long one? We take the long one. This one actually is y4 minus the y3, So delta y actually is a y4 minus y3. Understand? Then you can get this distance, yeah, the delta y between these two. We take the long minus the short, y4 minus y3, so we get the delta y. This one, separation between the what I can say the fourth order bright fringe and the third order bright fringe. That's a separation. Now, how about the dark fringe? Yeah, we already got the bright fringe. How about the dark fringe? Actually, it's the same. Now, if you're using dark fringe, let's talk about that. Now here, this one is for bright fringe. This one is for bright fringe because it is using m lambda. See here. If we're using dark fringe, how about dark fringe? Let's talk about dark fringe. Let's talk about dark fringe. If we are using dark fringe, the formula for the ym is using m plus half lambda d over d, isn't it? M plus half lambda d over d. That means, which is what about the delta y? So let's talk the delta y about the two dark fringe. Okay, I'm using the let's talk about fourth order. Okay, delta y, I just taking another 2 also, which is also the y4 minus y3. Yeah, y4 minus y3 for the dark fringe. Yeah. So y4 minus y3. So what is y4? Y4 is actually 4 plus 4 plus half lambda d over d minus the 3 plus half lambda d over d. So what do you think? What do we get? Of course, the half and half is cancelled out, isn't it? Half and half is cancelled out. In the end, you still get 4 minus 3. 4 minus 3, in the end, you still get the same thing. You still get 4 minus 3, you still get 1 lambda d over d. The delta y between the two dark fringe, is still 1 lambda d over d. It's the same as the delta y. It's the same as the delta y between the two bright fringe. Understand? Yeah. See that? This just now we got the delta y between the two bright fringe. The delta y between the two bright fringe is lambda d over d. So the delta y between the two dark fringe also lambda d over d. It's the same thing. 4 lambda minus 3 lambda, you get 1 lambda. This one, 4 plus half lambda minus 3 plus half lambda, the half cancelled, then still 4 lambda minus 3 lambda here. So you still get back the lambda d over d. So that's why we can say separation between the two consecutive bright fringe or dark fringe is the same. Delta y equal to lambda d over d. Okay. Now, okay, we have finished about that. So, what's the consequence of this delta y separation? Very big difference. Okay, let's look. Delta y equal to lambda d over d. If you're very, this is a very important equation. If you are using a longer wavelength, the separation between the two fringes is bigger. If the distance of the screen is further away from the double slit, the separation also become bigger. If the distance between the two slits, the two double slit is smaller, you get delta y also bigger. What I mean by this? Okay, what I mean by this? Again, delta y equal to lambda d over d. So if using, let's say, you have longer, let's talk about lambda. If longer wavelength, you get a higher wavelength, bigger delta y. What does it mean? Let's compare between the two wavelengths. Let's say I have using red light, I using wavelength red, and I using the blue wavelength is blue. Okay, we know that the wavelength of red is bigger. Maybe normally is 700 nanometer. For blue is almost like 400 nanometer. Okay, so what's the difference? If you're using a longer wavelength, red light has a longer wavelength, but the blue one has a smaller wavelength. Okay, what's the difference? If using the double slits, if you use on the double slits, what I can say is I should draw. Okay, the double slits. Okay, so if you shine the red light over here, you use the red light, the red wavelength. What you can see on the screen is the fringes are much further apart. That means if you are using a longer wavelength, the separation is further apart. That means this is the first central bright fringe. This is the first bright fringe. Is further apart. This is a central. This is a central bright fringe, and this is the first order bright fringe. They are further apart. Understand or not? The separation between the two bright fringe. But if you are using blue light, let's draw out. If you're using blue light, I shine with the blue light. Lambda blue. So what do you expect on the screen? You will surely see if the lambda, because just now we using red light is a long wavelength, so the delta y, you will get delta y also is bigger, but now your delta y is your lambda is small, So that means your delta y also small. Understand not? Delta y also small. That means you can see the fringes for lambda blue, which is smaller, which so the separation is nearer to each other. Like that. You can see more fringes. You can see more fringes on the screen. So what I can say is this is the zero order bright fringe. This is the first order bright fringe, and this is the second order bright fringe. The separation is much smaller. The separation is much smaller. Yeah, this one lambda is bigger, delta y bigger. This one lambda smaller, delta y also become smaller. The separation between the two fringe is we can say this one, the fringes are further apart from each other. Yeah, this one, the fringes are closer to each other. Closer to each other. And you can see this one, you can see less fringe on the screen. Less fringe. Yeah, this one you can see more fringe. You can see more fringes on the screen. Understand? Lambda is only one factor. Lambda can only one factor. Sometimes you put in the water. You put the whole apparatus in the water. You know, you put the whole apparatus. You put the whole apparatus into the water. We know also if in the water also affect the wavelength. Also affect the wavelength. We know that V equal to F lambda. V equal to F lambda, isn't it? V equal to F lambda. When we put into the water, the lambda becomes small. Because why? The lambda becomes small because the frequency is equal. The frequency is constant, but because the wave travel much slower, okay, the wave travel slower in water. Wave travels slower in water. That means the V becomes smaller. Yeah, if you put the apparatus, immerse the apparatus in the water, the wave travels slower in the light wave travels slower in the water, so the velocity decreases, the wavelength also decreases. So this will also end up to be, if the wavelength becomes smaller, the delta y, which is equal to lambda d over d. So when the lambda becomes smaller, just want to so when the lambda becomes smaller, the delta y, the fringes also become smaller. That means they're even closer to each other. The fringes also become closer to each other. Okay. So that's the thing. You put in the water, different medium also affect the wavelength. Wavelength also becomes smaller. The delta y also becomes smaller. So this is another factor. And then we have another two factor. If big D, if you put the screen even further away, yeah, you compare. Okay, let's look at this one. If you are putting the slits, okay, let's draw. Okay, you put the slits very. Okay, I put the double slits very close. Put the screen very. This is the screen. Okay, the D is very small. Okay, compared to you put the screen very far away. Okay, let's talk about this one. If we're putting very far away, like this one, putting the screen very far away. Okay, like this one. See this one? The big D. This is a screen. Yeah. Now it's very far away. Very far away. So the if this small, you can this small, the delta y also, small. Yeah, delta. See that? If the d is big, the delta y also big. Yeah. If delta d is small, delta y is small. That means very close to each other. Wait. When that d over d, very close to each other. Yeah, very close to each other. You can see delta y very small. That means I can see the fringe very close to each other. If the d is very big, then surely you can see the fringes much further apart. The delta y also become bigger. If the screen is closer, you can see fringes closer to each other. The big D is further away. The delta y also become bigger away. How about the separation between two slits? This one, if you make it smaller, then delta y become bigger. That means what I can say, the separation. To have a nice interference, okay, let's talk about how if the separation is very small. If the separation, the separation between the two slits, this is the delta, this is the small d. If the separation is very small, okay, the separation between two slits is very small, I can say what? Delta y equal to lambda d over d. When the separation is small, the delta y is very big. So that means I can see the fringes further away when the small d is very small. But if let's say the separation is very big like this, very far apart, the separation between the two slits is so big. If it's so big, the interference pattern is very close to each other. Delta y equal to lambda d over d. Okay, maybe I should write blue. Okay, so if the separation is very big, then delta y become very small. That means I can see like the delta y is very small. I cannot see I can see it's very small. Yeah, like that lah. If very big, can see very small, we can see very big. So that's a separation between the two slits. Understand? That's the thing. Yeah, the relationship between this formula. Okay. This is the thing lah. Right. Okay. So yeah, that's all for this subtopic. And I just want to the number of fringes versus order of fringes. I will talk later on in the following videos. Yeah, before we talk about this, later on I will summarize for all after we have learned double slit, single slit, and diffraction grating. Then I will summarize about these. This one we will talk about it later on. Okay. Thank you very much. See you in the next videos. Yeah.